Welcome back to my Terraform series. In this video, we are taking things to the next level. We will learn how to manage multiple resources in a single configuration and make our setups more dynamic using variables. Trust me, this is a game changer for scaling and flexibility in Terraform. Let's get started. Managing multiple resources allows you to build complex infrastructure setups. For example, you want to create an EC2 instance, an S3 bucket, and a security group, all in one configuration. But hard coding values for every resource, that's not efficient. That's where variables come in. Variables make your configurations reusable and dynamic, saving you time and reducing errors. Let's create an EC2 instance and an S3 bucket in the same configuration. So open your main.tf file that we have created in the previous video and add this code to your main.tf file. So we will use the same resource from our previous video for the EC2 instance, and this time we will add this code snippet here like this. And then this time we have one AWS instance resource type, and one resource type will be AWS S3 bucket. Now let's make this configuration dynamic by introducing variables. We will replace hard-coded values like the AMI instance type, and the bucket name with variables. Create a new file and name it variables.tf, and then put this code snippet there. So this is variable of AMI with the default value, this AMI value. And I will change it to the AMI value that I have here, and I will put it here. Then update your main.tf file, and inside the main.tf file, in the AMI attribute, you don't need to hard code your AMI ID. All you need to do is dot AMI. Why I am using AMI? Because in the variables.tf file, you can see that I have defined one variable with the name AMI. So I will use var AMI. So with that, I will be able to get this value, that is the default value, inside my EC2 instance resource. Then in the second resource, that is S3 bucket, I will remove this hard-coded name. Instead of hard-coded name, I will say var dot bucket name. And if I come back to my variables.tf file, you will see variables bucket name. And now we can pass the value for these variables when running the Terraform. So what I will do is now I will do Terraform init to initialize my project, and then I will plan the Terraform with the flag -var equals to bucket underscore name equals to my dynamic bucket. So here you can see the bucket name is the variable that we created here, and then we are assigning a name to this bucket, my dynamic bucket. Terraform will use the default values for the AMI and instance type. Instance type, I missed this one actually. So I need to change this instance type as well, where I need to do var dot instance type. So with that, I will get this. And I can also change this variable as well if I want. What I will do is I will create another variable here like this, and I will give this variable a name az, and then I will give it a default name of US East 1A, and then I will remove it from here and I will say var.az. So with that, I will be able to get this value, which is a default value. So we are going to pass bucket name, az, instance type, and AMI using this variable.tf file. But for the bucket name, we will be passing the name of the bucket name from this command by using -var flag equals to bitbucket, the variable name equals to the bucket name. So when you run this, you will see Terraform is able to plan to show me the resources that I will get once I will do the Terraform plan command. So if I see here, Terraform will create an EC2 instance for me with the AMI of this that I have defined in my AMI here, and the availability zone that I have defined here, and then instance type that I defined here. And Terraform will create three bucket resource, and then the tags that I have defined here will be this, and the bucket name will be my dynamic bucket that I pass when I run the Terraform apply command, my dynamic bucket. So now we will run Terraform apply command. Terraform will provision both the EC2 instance and the S3 bucket with the specified configuration. So it will, so if I don't pass a flag that I passed in the previous what's called command, Terraform will ask me in the terminal to pass the value for var.bucket name, the name of the S3 bucket. So I will say my dynamic bucket. And now Terraform is taking acknowledgement from me that there will in the plan there will be two resources added, will be added, zero to change and zero to destroy. So I will say yes, and then Terraform will able to create, and Terraform will take acknowledgement from me. And I'll say yes, create it for me. And this time my dynamic bucket operation host key bucket already exists. So in AWS, bucket names should be names are global. Like the name, if the bucket is already created by someone, we won't be able to create the bucket with that name. So what I will do is I will change the name of the bucket now. Terraform is awesome. My dynamic bucket name. And now Terraform is going to refresh its state. And then I will say, yes, I want to create it. And this time I got my Terraform is awesome, my dynamic bucket name got created. So to validate, what we will do is to open S3 bucket for EC2 instance, and you need to search for S3 service. I will open this S3 service from here, and inside the EC2 instance service, I will see there is one instance running. If I see the Terraform example server got created again with the T2 micro instance type. And there is one bucket, Terraform is awesome, my dynamic bucket got created. And if you are developer, you must be familiar with a file named .env. So in .env, what we have, and then we have one file .get ignore. So in .env, we have key value pair, So value is sensitive data and key is your variable that is used in your code. So in the variables.tf file, you can see we have passed the default value. So default value values help make your configuration reusable without requiring constant input for commonly used settings. For example, in most of your EC2 instances, in this case like instance type, we have defined the default value is T2 micro. So the most of the time the instance type is same in most of the servers. So if the value is same in multiple instance types, then we can pass a default value. So we really don't need to make changes to that variable again and again. So that's why we will use a default value. Now, unless you explicitly override the instance type, Terraform will use T2 micro as default. So if sensitive values like API keys, passwords, or access tokens should never be hard-coded or committed to version control. Instead, use a file terraform.tfvars. So I will create a terraform.tfvars file to store such sensitive data, and we will put this file in gitignore file in gitignore file, so this file won't be committed on our GitHub like version control system was. And now this file won't be committed to version control. And the terraform.tf file, I will create my secret values. In this case, let's say bucket name is equal to terraform is awesome, my dynamic bucket two. So now I will do terraform apply, and this time terraform won't ask me to pass the bucket name, as we don't have a default value for the bucket. Now you can see Terraform is also my dynamic bucket name is there. The name was do. Yeah. So I will say yes. Plan shows that 1 to add, 0 to change, and 1 to destroy. So what is about to be destroyed? S3 bucket that we created previously. So now you can see the bucket name is sensitive value forced to replace because we are going to make this change now. I will say yes. You see that the Terraform is awesome. My dynamic bucket 2 has been created. And now I will refresh the page and you will see a new bucket will be created and the previous one will be deleted. You see now the Terraform is awesome. My dynamic bucket 2 has been created. And now we will destroy whatever we have created. So we won't be charged for it. What I will do is I will run Terraform destroy command. Now Terraform will destroy whatever is mentioned in this main.tf file. Now you can see two resources to be destroyed. One is AWS instance and the other one is S3 bucket. I will say yes, and you can see bucket destruction complete. And now it's deleting EC2 instance, still destroying. I will pause my video and come back again once it's complete. You can see now two resources has been destroyed, and to validate we will go to AWS console and we will refresh our S3 bucket page. You will see no buckets. And in the EC2 instance, if I will refresh my page, you will see the instance type was running before. I will remove this filter and you see the instance is terminated. Thanks for watching. Remember, Terraform is all about automating and simplifying your infrastructure. Experiment with variables and let me know how you use them in your projects. See you in the next video.